Arc fault circuit interrupters, or AFCIs, detect and interrupt electrical arcs, which are a major cause of electrical fires. Arcing can occur in loose connections, damaged insulation, or frayed wiring. AFCIs provide an additional layer of protection against electrical fires, especially in areas with older wiring. Many newer electrical codes require AFCI protection for lighting circuits in residential dwellings. Since the existing multiwire branch circuit cannot be AFCI protected, it would be necessary to remove the portion of the multiwire circuit that serves the top floor and connect it to the new AFCI protected circuit. Run a separate neutral wire with the new circuit to provide a complete circuit path. Separating the lighting load between two circuits reduces the risk of overloading the existing circuit and the likelihood of it failing. Installing an AFCI protected circuit ensures that the top floor lighting is protected against arc faults. Bringing the electrical system in line with current code requirements provides peace of mind and potential resale value. It is highly recommended that the new circuit serving the top floor lighting be AFCI protected to enhance safety and address the concerns about load distribution and potential circuit failures. Electrical safety is paramount when dealing with residential wiring, particularly in older homes. Understanding the function and benefits of AFCIs is crucial for preventing electrical fires and ensuring compliance with current electrical codes. When considering adding a new circuit to an existing electrical system, it's essential to evaluate the existing wiring and its limitations. In situations where an existing multi-wire branch circuit is present, it's important to understand how to properly separate and protect the new circuit. A multi-wire branch circuit shares a neutral conductor between two or more circuits. While this configuration can save on wiring costs, it also presents challenges when it comes to AFCI protection, as standard AFCIs are designed for single circuits. To address this, it's recommended to separate the multi-wire circuit and run a dedicated neutral wire for the new AFCI protected circuit. This ensures that the AFCI can properly monitor and detect arc faults without being affected by the shared neutral. When separating the multi-wire circuit, it's crucial to disconnect the existing wiring and connect it to the new AFCI protected circuit. Be sure to properly label the wiring and follow all applicable electrical codes. A qualified electrician should perform the electrical work to ensure safety and code compliance. The new AFCI protected circuit should be wired using appropriate gauge wiring and connected to a dedicated breaker in the electrical panel. The breaker should be sized according to the load requirements of the circuit, and it's important to avoid overloading the circuit. In addition to providing arc fault protection, separating the multi-wire circuit also improves load distribution. By dividing the lighting load between two circuits, you reduce the risk of overloading the existing circuit and causing it to fail. This can help prevent nuisance tripping of the breaker and ensure that the lighting system operates reliably. Furthermore, separating the multi-wire circuit brings the electrical system in line with current code requirements. Many newer electrical codes require AFCI protection for lighting circuits in residential dwellings, and separating the multi-wire circuit allows you to meet these requirements. This can provide peace of mind and potentially increase the resale value of the home. In summary, installing an AFCI protected circuit for the new lighting circuit is highly recommended. This enhances safety, improves load distribution, and ensures compliance with current electrical codes. When dealing with older homes and existing multi-wire branch circuits, it's essential to understand the limitations of the existing wiring and take steps to properly protect the new circuit. By following these recommendations, you can create a safer and more reliable electrical system for the home. Remember to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes. Always prioritize safety when working with electricity. Electrical work can be dangerous if not performed properly, and it's important to take all necessary precautions to protect yourself from electrical shock. When working with electrical wiring, be sure to turn off the power to the circuit at the breaker panel. Use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Electrical safety is not something to take lightly, and it's always better to be safe than sorry. By following these safety guidelines, you can minimize the risk of electrical accidents and ensure that your electrical system is operating safely and reliably. Let's delve into the specifics of arc fault circuit interrupters, or AFCIs, and their importance in modern electrical systems. AFCIs are designed to detect and interrupt electrical arcs, which are a common cause of electrical fires. Arcs can occur in various situations, such as loose connections, damaged insulation, or frayed wiring. These arcs generate heat, which can ignite surrounding materials and lead to a fire. Standard circuit breakers are designed to protect against overloads and short circuits, but they are not able to detect the subtle characteristics of arc faults. AFCIs, on the other hand, use sophisticated electronics to monitor the electrical current and detect the telltale signs of arcing. When an arc fault is detected, the AFCI quickly trips the circuit, cutting off the flow of electricity and preventing a fire from starting. There are two main types of AFCIs: branch and combination. Branch AFCIs protect against arc faults in the branch circuit wiring, while combination AFCIs protect against both branch circuit and series arc faults. Combination AFCIs are generally recommended for use in residential dwellings, as they provide the most comprehensive protection. When installing AFCIs, it's important to follow the manufacturer's instructions carefully. The AFCI should be installed in the electrical panel and connected to the circuit wiring. It's also important to test the AFCI regularly to ensure that it is functioning properly. Most AFCIs have a test button that can be used to simulate an arc fault and verify that the device is tripping. If the AFCI fails to trip when tested, it should be replaced immediately. In addition to providing arc fault protection, AFCIs also offer other benefits. They can help reduce the risk of electrical shock by detecting and interrupting ground faults. Ground faults occur when electricity flows through an unintended path, such as through a person's body. AFCIs can quickly trip the circuit in the event of a ground fault, preventing serious injury or death. AFCIs are an essential component of modern electrical systems, and they play a critical role in protecting homes and families from electrical fires and shocks. By understanding the function and benefits of AFCIs, you can make informed decisions about your electrical system and ensure that it is operating safely and reliably. The National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment in the United States. The NEC is updated every 3 years, and it reflects the latest advancements in electrical safety technology. The NEC requires AFCI protection for many circuits in residential dwellings, including those that serve bedrooms, living rooms, dining rooms, and other areas. The specific requirements for AFCI protection vary depending on the edition of the NEC that is in effect, so it's important to consult the latest version of the code to ensure compliance. In addition to AFCI protection, the NEC also addresses other aspects of electrical safety, such as grounding, bonding, and overcurrent protection. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. This helps prevent electrical shock and reduces the risk of fire. Bonding is the process of connecting metal parts of electrical equipment together to create a low impedance path for fault current. This helps ensure that the equipment is properly grounded and that any fault current will flow back to the source quickly. Overcurrent protection is the use of circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to trip the circuit when the current exceeds a certain level, preventing damage to the wiring and equipment. The NEC provides detailed requirements for grounding, bonding, and overcurrent protection, and it's important to follow these requirements carefully to ensure the safety of the electrical system. When working with electrical wiring, it's essential to have a thorough understanding of the NEC and to follow its requirements closely. The NEC is a complex document, and it can be difficult to interpret its requirements. If you are not comfortable working with electricity or interpreting the NEC, it's best to hire a qualified electrician to perform the work. Let's consider a specific example of how AFCI protection can be implemented in a residential dwelling. Suppose a homeowner is adding a new bedroom to their home. The NEC requires AFCI protection for the lighting and receptacle circuits in the bedroom. To comply with this requirement, the homeowner would need to install AFCI circuit breakers in the electrical panel to protect the bedroom circuits. The AFCI circuit breakers would monitor the electrical current and detect any arc faults that may occur in the bedroom wiring. If an arc fault is detected, the AFCI circuit breaker would quickly trip the circuit, cutting off the flow of electricity and preventing a fire from starting. In addition to installing AFCI circuit breakers, the homeowner would also need to ensure that the bedroom wiring is properly grounded and bonded. This would help prevent electrical shock and reduce the risk of fire. The homeowner would also need to install tamper-resistant receptacles in the bedroom to prevent children from inserting objects into the receptacles. Tamper-resistant receptacles have a built-in shutter mechanism that prevents objects from being inserted into the receptacle unless a plug is inserted. By following these steps, the homeowner can ensure that the new bedroom is wired safely and in compliance with the NEC. Remember, electrical safety is paramount when dealing with residential wiring. It's important to take all necessary precautions to protect yourself and your family from electrical hazards. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Let's explore the different types of electrical faults that can occur in a residential wiring system. Electrical faults are abnormal conditions that can cause damage to the wiring, equipment, or even pose a safety hazard. Firstly, we will examine short circuits. A short circuit is a low-resistance connection between 2 points in a circuit that are at different voltages. This can cause a large amount of current to flow through the circuit, which can damage the wiring and equipment. Short circuits are often caused by damaged insulation or loose connections. Secondly, ground faults are a type of electrical fault that occurs when current flows through an unintended path to ground. This can happen if the insulation on a wire is damaged or if a metal part of the equipment comes into contact with a live wire. Ground faults can cause electrical shock and can also damage the wiring and equipment. Thirdly, arc faults are a type of electrical fault that occurs when electricity jumps across a gap in the wiring. This can happen if the insulation on a wire is damaged or if there is a loose connection. Arc faults can generate heat and can cause a fire. AFCIs are designed to detect arc faults and trip the circuit, preventing a fire from starting. Fourthly, overloads are a type of electrical fault that occurs when too much current is flowing through a circuit. This can happen if too many appliances are plugged into the same circuit or if there is a problem with the wiring. Overloads can cause the wiring to overheat and can damage the equipment. Circuit breakers are designed to protect against overloads and trip the circuit, preventing damage to the wiring and equipment. By understanding the different types of electrical faults, you can take steps to prevent them from occurring and to protect yourself and your family from electrical hazards. Regular inspections of the wiring and equipment can help identify potential problems before they cause a fault. It's also important to follow proper wiring practices and to avoid overloading circuits. If you suspect that there is an electrical fault in your home, it's important to call a qualified electrician to investigate and repair the problem. Let's discuss the importance of regular electrical inspections. Regular electrical inspections can help identify potential problems before they cause a fault. A qualified electrician can inspect the wiring, equipment, and electrical panel to look for signs of damage, wear, or corrosion. They can also test the AFCI receptacles and AFCI circuit breakers to ensure that they are functioning properly. During an electrical inspection, the electrician will typically check the following items: wiring. The electrician will inspect the wiring for signs of damage, such as cracks, fraying, or exposed conductors. They will also check the connections to ensure that they are tight and secure. Equipment. The electrician will inspect the electrical equipment, such as appliances, lighting fixtures, and outlets, for signs of damage, wear, or corrosion. They will also check the grounding and bonding connections to ensure that they are properly installed. Electrical panel. The electrician will inspect the electrical panel for signs of damage, such as rust, corrosion, or loose connections. They will also check the circuit breakers and fuses to ensure that they are properly sized and functioning properly. AFCI receptacles. The electrician will test the AFCI receptacles to ensure that they are tripping properly. AFCI receptacles are designed to protect against electrical shock and should be tested regularly. AFCI circuit breakers. The electrician will test the AFCI circuit breakers to ensure that they are tripping properly. AFCI circuit breakers are designed to protect against arc faults and should be tested regularly. If the electrician finds any problems during the inspection, they will recommend repairs or replacements. It's important to follow the electrician's recommendations to ensure the safety of the electrical system. Regular electrical inspections are an important part of home maintenance. They can help identify potential problems before they cause a fault and can help ensure the safety of the electrical system. Let's consider some common electrical safety tips. Electrical safety is essential for protecting yourself and your family from electrical hazards. Firstly, never overload circuits. Overloading circuits can cause the wiring to overheat and can damage the equipment. Avoid plugging too many appliances into the same circuit. Secondly, use extension cords safely. Extension cords should only be used temporarily. Avoid using extension cords as a permanent wiring solution. Use extension cords that are rated for the amount of current that will be drawn by the appliances that are plugged into them. Thirdly, keep electrical equipment away from water. Water is a conductor of electricity. Keep electrical equipment away from water to avoid electrical shock. Fourthly, inspect electrical cords and plugs regularly. Inspect electrical cords and plugs for signs of damage such as cracks, fraying, or exposed conductors. Replace damaged cords and plugs immediately. Fifthly, use GFCI protection in wet locations. GFCI receptacles are designed to protect against electrical shock and should be used in wet locations such as bathrooms, kitchens, and outdoor areas. Sixthly, test GFCI receptacles regularly. Test GFCI receptacles monthly to ensure that they are tripping properly. Seventhly, use AFCI protection in bedrooms and living areas. AFCI circuit breakers are designed to protect against arc faults and should be used in bedrooms and living areas. Eighthly, test AFCI circuit breakers regularly. Test AFCI circuit breakers monthly to ensure that they are tripping properly. Ninthly, call a qualified electrician for repairs. If you suspect that there is an electrical problem in your home, call a qualified electrician to investigate and repair the problem. Tenthly, never attempt to repair electrical equipment yourself. Electrical repairs should only be performed by qualified electricians. Following these electrical safety tips can help protect yourself and your family from electrical hazards. Remember, electrical safety is not something to take lightly. It's important to be aware of the risks and to take precautions to avoid electrical accidents. The customer's 1940s era home presents unique considerations for electrical safety. Homes built in that era often have older wiring that may not meet current safety standards. The insulation on the wiring may be brittle or cracked, and the wiring may not be properly grounded. It's important to have the wiring in the home inspected by a qualified electrician to determine if it needs to be upgraded. Upgrading the wiring can improve the safety of the electrical system and reduce the risk of electrical shock and fire. If the wiring is upgraded, it's important to use appropriate gauge wiring and to follow all applicable electrical codes. It's also important to install GFCI protection in wet locations and AFCI protection in bedrooms and living areas. In addition to upgrading the wiring, it's also important to replace any damaged or worn electrical equipment. This includes appliances, lighting fixtures, and outlets. Damaged or worn electrical equipment can pose a safety hazard and should be replaced as soon as possible. It's also important to make sure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source and helps prevent electrical shock. By taking these steps, the customer can improve the safety of the electrical system in their 1940s era home and reduce the risk of electrical accidents. Remember, electrical safety is paramount when dealing with older homes. It's important to be aware of the risks and to take precautions to avoid electrical hazards. When adding a new circuit to the home, it's important to consider the existing electrical system and to make sure that the new circuit is compatible with the existing system. The new circuit should be wired using appropriate gauge wiring and should be connected to a dedicated breaker in the electrical panel. The breaker should be sized according to the load requirements of the circuit, and it's important to avoid overloading the circuit. It's also important to install AFCI protection for the new circuit. AFCI protection will help protect against arc faults and reduce the risk of fire. By following these steps, the customer can safely add a new circuit to their home and improve the functionality of their electrical system. Always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes.